All right, today we're finishing up section 3.2. So we're looking at really a lot of review. A lot of this stuff we've talked about this, we've done stuff with this in the past. We all know what function notation is. We know what it is to evaluate functions. We've done it already this year, but we'll extend this stuff just a little bit. So first of all, function notation. So we can take, we're going to be working on putting linear equations into certain forms. What form is that in, by the way? We haven't talked about this yet. Yes, okay, that's slope-intercept form, y equals mx plus b form. We'll look at ultimately we'll have three different forms of linear equations that we'll learn how to use, and why would we need three. We'll talk about why each one is kind of important in its own way. But when we're graphing equations of lines, we typically want to have x's and y's because we have x coordinates and y coordinates when we make our t-tables, right? If we're doing something slightly different, if we're using functions to plug in values, to plug in inputs and find output values, I mean, that would work, but there's a better way to write them. We would use function notation instead. And how would we change this equation to put it in function notation? If earbuds need to be away. People have earbuds out. Put those away, please. So what would I do to change this equation, to put it in function notation? What's function notation? Instead of y, I use what? F. Say it again? F of x. There you go. So I would just call this f of x instead of y, and it's the same. F of x equals 2x plus 7. And you've been saying since Algebra 1 that f of x is just a fancy name for y, right? It serves the same purpose. It's just a different notation. When it's in function notation, the whole point is that it's telling me I'm going to be inputting values of whatever the variable is that's in the parentheses and calculating the output values by plugging in those types of inputs. So in the blue equation up here, when we write this in function notation, which variable is the input variable? What is it? Well, no, I mean, but in this, I want to know what's the input variable. X, absolutely. And how do you know? Because it's the variable that's in the parentheses in function notation. That's always the way it works. The variable that shows up in the parentheses is the input variable, right? So X is the input. Now, normally the output we would have called Y, right? That's our output variable. What do we call it here?
F of x.
F of x. F of x is the output variable, okay? That gives us the output values. And we know how to do something like this problem. We're given a function in function notation, f of x equals 2x plus 7, and it asks us to evaluate the function at -3, f of -3. What am I doing when I calculate f of -3? Yeah, that's just the plug and chug stuff we did earlier, right? You're just going to plug in that x value into the equation and then simplify. Just chug through order of operations and get a simplified answer, right? So we just get 2 times, instead of x, we're replacing that with -3. And remember, when we plug in a value, when we evaluate a function and we plug in a value, we always put it in parentheses every time. And if we didn't, that would be sort of confusing, right? If I wrote that without parentheses, that would be kind of weird if I said f of -3 equals 2 -3 plus 7. That doesn't look like multiplication. It looks like subtraction in that case, right? You avoid that, though, if you always include everything in parentheses. You never have that problem. You always know exactly what operation is there. You're multiplying when something is in front of parentheses. Okay, so we can do stuff like this. Like if we were going to do problems 2 or 3, what would I do in problem 2? Look, it gives me two functions. It gives me f of x up here and it gives me g of x. What am I doing in problem 2?
Substituting x for 3/10.
Good, I'm substituting 3/10 for all the x's in f of x, right? And if I do that process, it's kind of a little bit cumbersome because we've got a bunch of fractions in there to deal with. But we could hammer through the fractions and get an answer. I'm going to remind you of a shortcut we have, of a technology tool that's very useful. What would we do in number 3? Okay, we're going to use Desmos, aren't we? In number 3, I would take this g of x function, which is even more complicated, negative x squared plus 9x minus 1, and I'm going to substitute for all the x's 0.4, putting it in parentheses. But again, we can do this, but it's a lot of arithmetic, and this is where Desmos comes in handy, right? What we would do, and you guys all know how to do this, or I think you do. You should. But in case you can't, let's remind ourselves. How about? So I've got Desmos graphing here. If I want to do number 3, what do I do? Okay, but before I can do that, what do I have to do? Okay, good. I need to define g of x. So g of x is equal to negative x squared. Oops, that's not right. Negative x squared plus 9x minus 1. And then I just go down. Oops, I put a c in there, didn't I? There we go. And then we go down and we're going to do g of 0.4. And what's it tell me? 2.44. Okay, so 2.44 is my answer. And is that correct? Yeah, it is. What do you know? Okay. Okay, so that's how we could get that answer a lot more easily with technology, right? Okay, give me thumbs. Does that ring a bell? Remember how to do all that stuff? Okay, what about number 6? How do I say that, first of all? What are they asking me to do? Raise hands here. What are they asking me to do here? Okay, but how would you say that? 2 times what? G of 12. Yeah, it's just 2 times G of 12. Here's how you think about that. What is G of 12? Well, G of 12, anytime you see a function of a specific value like that, when I've got a number inside a function, you automatically are just thinking, okay, that's no big deal. That's just an output number that I could calculate, right? G of 12 is just an output number. It's the output number I get for the function g when I input a 12. And I could go up to my g of x and plug it in and find out, or I could use Desmos, right? Either way, I'm just calculating a number, and then what am I going to do with that output number, g of 12? What am I doing? What am I doing to g of 12? What am I doing? Multiplying by 2. Yeah. It's just 2 times that output number. Okay, so if I want to come up with an answer here, I want to come up with a number answer, what's going to be the first step in calculating 2 times g of 12? What's the first step? I got to evaluate g of 12, don't I? I need to figure out what g of 12 is, which means I'm going to plug 12 into the function g and see what we get. Now, we could use Desmos, or we could just plug it into the equation up here, right? Every place I used to have an x, I've got a 12 in parentheses. Everybody agree that 12 squared is 144? And so negative 12 squared, negative, the negative is not inside the parentheses, is it? Because 12 was the value that I input for x. 12 squared is 144 times my negative 1 makes it negative 144. Because remember, I have to do exponents before multiplying by negative 1 in PEMDAS, right? 9 times 12 is 108, so we add 108, subtract 1. When all the dust settles, we get negative 37 for g of 12. So is that our answer?
No.
Now we got to multiply that output number times 2. 2 times negative 37 is negative 74. Okay? Give me thumbs. Make sense? The order in which we do that stuff? We have to first find the output number, then we multiply it by 2. Okay? All right. Okay. complete the ordered pair. How would I do that? So it says the function f of x equals 4x squared minus 3 includes the ordered pair negative 4 blank. What would I do? Jalen? Yeah, right? If I were going to graph this function, which we'll do later in the year, it's a quadratic function. Anybody know what kind of shape we're going to get when we graph that? Not a quadrilateral. I know you're thinking of the right thing. What do you call that? What's the shape? Kind of a U shape, right? What do we call those? No. No. What it starts with a P. What is it? No. You guys are thinking about geometry. You're still stuck in geometry mode. It's a parabola. Parabola. Okay. So it's a parabola, which is if I graph, and again, I'm looking, this is way in the future for us this year. We'll review this. But remember, a parabola is just a big U-shaped graph, right? So if I were to graph this parabola, which we'll do later in the year, if I were to graph that parabola, I would find that one of the points that's on that graph is going to be the ordered pair negative 4 blank. Well, how do I know? If I want to know the output y coordinate, I just have to input the x coordinate negative 4 into the function, right? And so what do I get if I do that? Well, I'm going to input negative 4 into the function and just simplify to see what the corresponding output value is. Okay, what's negative? What do I do first here if I'm simplifying? Think PEMDAS. Exponents first, right, if I'm simplifying. E comes before, exponents before multiplication and division, which is before addition and subtraction. So what is negative 4 quantity squared? 16. Good. So I get 4 times 16 minus 3. What's 4 times 16?
64.
64. 64 minus 3 is 61, which is our output value. That's the y coordinate that we get when we input that x coordinate. Okay, everybody see that? Yeah. Okay. Remember, ordered pairs are always just a collection of an input value on the left and the output value on the right. That's it. That's what an ordered pair always is.
If you just had the output value, how would you solve it?
Okay, if I had the output value, that's a good question. If they gave me, what if they gave me this? Very good question. What if they gave me, then what would I do to my equation up here? Where would I plug that?
61 equals 4.
There you go. That would be a value of f of x. So I would plug that in for f of x, and I would get the equation 61 equals 4x squared minus 3. And I would solve that equation, which we'll learn how to do later in the class. Okay, solve that quadratic equation. Okay, good question. I like it. Okay, here's another representation. This time, the function is not defined as an equation. They just give me a set of ordered pairs. Raise hands here. Don't say it out loud. I'm just going to, if you have your hand raised, that's a good thing. I might not call on just hand. I might pick other people too. What is f of 7? What's f of 7 here? Based on that function, which is just a set of 3 ordered pairs. Mackenzie, what's f of 7? What do you think? Okay, so now if I do f of 7, what's my input? What's the input number? 7. Okay, so I'm inputting a 7. What is it? It's negative 1, right? Because if I'm inputting a negative 7, I want to pick the ordered pair that has negative 7 as an input value, right? Input value is the x coordinate, so that means right there. Everybody see that? Yeah, click those close. Keegan, click that close. Click that close. So if I'm inputting 7, what is this ordered pair telling me my output is? Negative 1. Right? Everybody see that? There's my output, negative 1. Okay? Give me thumbs on that. How are we doing? Up, down, sideways.
It's like
Okay.
f of -3 would be 7.
That's right. F of -3 would be 7, exactly. Okay. Same question, different representation. There's a different way of representing the function as a mapping. Okay, raise hands. Raise hands. What is, Donovan, what is f of 2? 2. And you know because of that arrow, right? I'm inputting a 2 and it's outputting a 2. Whoops. Okay, give me thumbs. Make sense? Okay. And really all this is, a function is just a way of linking an input to an output. Now, most of the year in Algebra 2, the way we're going to link the inputs and the outputs is through some equation. But it doesn't have to be. It could be other stuff too. Okay, what about this one? F of x is defined as 4. F of x equals 4. So what is f of -3? Anybody tell me?
4.
It's 4. What's f of 0?
4.
Yeah. Okay, why? Why? Because this is really similar to what we did in this first example. Not first, well, I guess kind of the first example right here. When we wanted to find f of -3, I just plugged -3 in for x, right? Okay, but look at this example. Are there any x's in the equation? No. The output is always 4. It doesn't matter what x is. The output is always 4 because there are no x's for me to plug a value in. F of any input value, any real input value is going to be 4. And how could we visualize that? Well, here's a way. F of x equals 4 is the same thing as the equation y equals 4, right? Think back. We haven't reviewed this stuff yet. That's coming up here this week. But everybody show me with your arms, what does the line y equals 4 look like? Yeah, that's a horizontal line, isn't it? It's a horizontal line. In fact, it's this line right here. There's the horizontal line. No matter which x value I input on that line, the y-coordinate of the point is always going to be 4, isn't it? Right? So f of -3 equals 4. Well, that corresponds to this point right there. F of 0 equals 4 corresponds to that point with coordinates 0, 4. But because it's a horizontal line, the y-coordinates are all the same, aren't they? They're 4. Okay? Everybody see that? Okay. So I gave you a complicated looking g of x, quadratic equation. Find and simplify g of 1/2. So first of all, is 1/2 an input or an output? Input. Yep, because it's going into the function, right? Replaces the x. So how would I do this? I would probably do this with Desmos, right? Plug that in with Desmos. Okay? And I can't remember if I set this up or not, did I? Yeah. I don't know where that went. There it is. Okay, so if I use Desmos, again, you guys know how to do this. I just define the function. And what do I do to find the answer? Yeah, now I guess I should have made this, probably that should have been g, right? Doesn't really make any difference, but call it g. So g of 1/2 is that, okay? Now, what if they want the answer as an integer or fraction? What do I do in Desmos? Click on the answer?
No, click on
Oh, click on the fraction button. There we go.
41.
So 41/4.
Or you go to Mathway and type it in.
Or you go where?
Mathway.
No, you don't go to Mathway.
Why not?
Mathway's no good. Don't go to Mathway.
Not cheating.
Yeah, that's kind of cheating. Don't go to Mathway.
I mean, kind of, it's definitely cheating.
Yeah.
Do you know from experience?
So there it is, 41/4. Okay? All right, we're almost there. Here's yet another way. So think about the examples we looked at. I've given you functions as equations, as sets of ordered pairs, as a mapping. This time I'm giving you a function as a graph. This is a graph of the function f of x. Okay, can anybody tell me, raise hands, don't say it out loud, can anybody tell me what f of 1 is equal to?
1.
What's f of 1 equal to? What do you get?
6.
How'd you get that?
I like the dot.
There you go. Okay, the point. The ordered pair is what gives it away, right? So f of 1 means I want to know the value of the output, which is y, when I'm inputting a 1. Okay, now look at this ordered pair. This ordered pair has coordinates x is equal to 1, y is equal to 6, right? So the y coordinate is 6. That means the output number is 6. That's it. Make sense? So we got all these different ways of doing it. Okay, now I'm going to throw a curve at you. This is a little different. Okay, I know you've been coasting here for a little while because this has just been a lot of review, but this one's a little different. F of x equals 3x plus 19, and the question says, if f of x equals negative 62, find x. Am I, thumbs up or down, am I plugging negative 62 into the function for x?
No, sir.
I'm not. I'm doing something different. What am I doing this time? Okay, kind of the opposite. Yeah. Keegan, what am I doing this time? If they're telling me f of x equals negative 62, where am I plugging that in? Is that an input or an output number?
Output. Input. No input.
Okay, well,
You replace the x with that?
no, am I replacing the x? That would be an input if that were an x value, but it's not. It's an output. It's a value of f of x, right? What did we say at the very beginning? I got to go back for a second here. We said that when we write something in function notation, x is the input. The output is the value of the function, f of x, right? That's an output. Okay, so then, so they're telling me the value of f of x, right? That's the output number. Where am I going to plug that in my equation?
You're going to like switch it for x.
There you go. I'm going to plug that in for f of x. Okay, that's an output. So we need to find the inputs, the x values, where the output f of x, which is just the y value, where that is negative 62. So I'm plugging negative 62 in. There, right? And I'm getting 3x plus 19 is equal to negative 62. Everybody agree? And then what do I do to find the x values? I have to just solve that equation, right? 3x plus 19 is equal to the output negative 62, so I subtract 19 from both sides. I divide by 3, and I get the input value where that happens is negative 27. Can anybody tell me an ordered pair on my function? Negative 27.
Negative 62.
Negative 62, right? Those are inputs and outputs that go together. We started with the input negative 62, and we found that the input that goes with that is negative 27. So we worked backwards this time. Give me thumbs. Okay? All right. I want to get you working on this stuff so you get some practice. We're almost there. Okay, so what about this guy? We're going to look at a little application here, right? Very briefly. So Owen paid a landscaping company $108 for an initial lawn treatment, then $74 per month thereafter. So just look at that first sentence up there. Does either one of those sound like a rate to you?
Yeah.
Which one sounds like a rate?
74 per month.
Yeah, and what gives it away? The per, there you go. The word per absolutely gives that away. When you see per, you know that's a rate, don't you? So we haven't talked about lines yet. That's where we're going. Again, I mean, this is kind of just foreshadowing what's coming over the next week. But does it make sense then that if I wanted to come up with a function that models this, the 74 would be multiplied by x, or in this case, t. It's the one that's getting multiplied by the input variable, right? Because when we write a line in the form y equals mx plus b. The slope is the rate, isn't it? That's the number that's multiplied by the input. Usually it's an x, in this case it's a t. What about the $108 for the initial lawn treatment? That's the b. That's the start value, isn't it? When we model a situation with a linear equation, isn't the b always the initial or the start value, right? Sometimes we call it fixed cost, or you've heard all those words, but usually it's start value. Well, that would be the start value. We pay that one time with our initial lawn treatment. That's it, one-time fee. And then after that, we're paying $74 per month. That's my rate. So this kind of makes sense, doesn't it? Yeah. This function. The function P of t equals 108 plus 74t represents the total amount of money he will have paid. So the output P of t is how much he's paid when my input is what? What does the input t represent?
24 months.
Well, the number of months, right? So t represents the number of months I've been on this contract, and P of t is telling me the output, how much I've paid after that t months. So then what does P of 24 represent, everybody? Is 24 an input or an output? It's an input because it's going into the function, isn't it, right? So it must be a value of t. So what is the 24? 24 months. And what does P of 24 represent?
108 plus 74 times 20.
Describe it though. What is that? Peyton, what's that mean? P of 24, I don't want a bunch of math. I want you to tell me what quantity, what does that represent in this application up here? P of 24, is P of 24 going to be an output or an input? Well, 24 is the input. What's P of 24? That's the output, right? That's the output I get when I input 24 into the function. Okay, so what are our outputs here? We're inputting months. What are we outputting from this whole situation? What are we calculating? Yeah, money, right? The amount we've paid. So this must be what then? P of 24 is the amount we've paid when?
Every month.
Well, P of 24 is what? We're inputting T is the number of months. That's 24 months. What are we calculating? How much he's paid after 24 months, right? Everybody see that? Okay. We input 24 and we calculate P of 24 represents how much he's paid after 24 months. Okay, make sense? Okay, that's what this whole thing, whatever the function is calculating, that's the output. Okay, and to find that, I would, just like everybody said, we would just plug in 24. We're just going to get some big number. Okay, that's going to be a big number. What am I going to get? What is it?
118.84. 1,884. I already did on the
Okay,
calculator.
okay, I believe you. So we get $1,884 if we plug that in evidently. Okay, that's just what we would calculate for our output. Okay, now what about the second part? It's a little different. How long has Owen been receiving lawn service if he has paid a total of $29.94 to date? Okay, so he has paid that much. Is that an input or an output? That's an output, yeah. So where am I going to plug that in my equation then? Okay, so that's, well, P of t, right? So I've got, in other words, I'm going to take my equation, my function, P of t equals 108 plus 74t, and I'm going to plug this in for my output P of t. That's an output number. It's a, right? It's a money amount that I've paid. That's what the output is calculating. Give me thumbs. Okay? And I would just get the equation then 29.94 equals 108 plus 74t, and they want to know how long has he been receiving lawn service. How would I find out? if I want to find out the question, how long has he been receiving lawn service, what would I do with that equation? Solve for t. There you go. Solve for t. Exactly. Okay. We plug a number in for the output and we solve for whatever the input variable is. So what would the steps be?
Subtract 108.
Those guys cancel. I get, let's see, that's going to give me 2886 equals 74t. Next step.
Divide by 74.
Okay.
48.
It's going to give me 2, no, I don't think so. It's going to give me 29, I think. Right?
That,
He did it on the short calculator.
it would be 39.
39, that's right. Yeah, 39. That's it. Yep, my mistake. So the answer is 39 months. Okay, give me thumbs. Make sense? Okay, all right. Hold on. I'm almost done. You got to see this part. Okay, so now, oh man. Okay, I'll give you a work day tomorrow. Okay, deal? Because this ate up a lot of time. Okay, so now I want you to see this pattern. I want you to see this pattern here. So they're telling us that f of x is negative 4x plus 9. Okay, so tell me real quick, how would I calculate f of 2? What am I doing? Okay, that's just telling me that I'm plugging in 2. Every place where I used to have an x, I'm now plugging in a 2. In other words, I'm replacing my input x's with 2's, right? So I get negative 4 times 2 plus 9, and I could simplify that down to a number. Okay, what would I do in this case? What if I asked you, what is f of a? If I input an a, what is that function telling me I'm going to get? You're doing the same thing, right? What did I do last time? I replaced my x's with 2's. So what am I going to do here? Replace the x's with a's. And I just get negative 4 times a plus 9. Okay, now that's a little weird. I don't get a number this time because I didn't input a number. I input a variable, and I got an expression with that variable. Okay, what's f of b? Negative 4b plus 9. Okay, here's the one. Now we're going to make a jump. What is f of the quantity c plus 2? Yeah, I'm just going to replace my x's with that whole quantity. That's it, right? That's the pattern. So we get negative 4 times the quantity c plus 2 plus 9, right? Everybody see that? Now I could simplify that. I could distribute the negative 4 and collect like terms, and we got it, right? Okay, last one. And again, I'll pay you off with a work day. I know that was a lot of stuff. We covered a lot of material today. So now what are we going to do here? I know this is a lot, but you got to really muster up some energy and focus here for 30 more seconds because this is important. This is one you're going to see all year long. You got to know how to deal with this. We do this sometimes for reasons in algebra. If I give you a function, f of x, a lot of times we want to know what happens if I evaluate that function at negative x. And it has to do with symmetry stuff that we'll talk about later, but this is really an important thing in algebra to do this. Well, we're going to follow the same rules. Every place I used to have an x, I'm going to replace that with the quantity negative x. So I get the quantity negative x squared minus 3 times the quantity negative x plus 1. I just have to simplify that. Well, first of all, what is the quantity negative x squared? X squared, exactly. It's like saying, what's negative 4 times negative 4?
16.
Positive 16. It's positive 4 squared. Negative x times negative x is just positive x squared, isn't it? Yeah. Negative times negative is positive. So then I'm just going to get x squared minus 3 times negative x is what? Plus 3x plus 1, and that's it. That's the function I get when I substitute negative x in. Okay? Good job. Work day tomorrow. You earned it.
I got called in. Yeah, so I was thinking tomorrow if class that would make it easier for me. And I know you can't grade papers, but it would